Fire is what people notice first. The glow, the sparks, the violence of heat and force. But inside this factory,
what looks like brute force is actually controlled precision. Every second, every temperature, every strike changes the steel.
And every mistake can follow the metal all the way to the finished part.
most people think the answer is heat. But heat alone cannot create strength, consistency, or reliability. In modern forging, quality comes from control. Across the United States, forging plants turn raw steel into components built for punishing conditions. Parts for transport, energy, construction, and heavy industry begin here. Long before they enter the real world, they must survive this one. Step inside, and the first impression is scale. Heavy machinery. Overhead cranes. Furnace heat rising through the air. But beneath the noise is a carefully managed process.
Forging quality steel begins before the furnace is even switched on.
The process starts with the raw stock, billets, bars, or preformed steel shapes. If the starting material is inconsistent, the final product will be too.
Composition matters. Purity matters.
Size, chemistry, and consistency all shape what the steel can become under pressure.
Before forging begins, the stock is cut to size. Each length is chosen for the part it will become. Too much metal wastes energy. Too little metal compromises the form.
Even here, quality depends on discipline.
Forging is not a process that can be corrected at the end. Good results are built into the steel from the start. Then comes the heat. Not to melt the steel, but to make it workable.
In forging, the goal is not liquid metal. The goal is controlled deformation.
The steel must be heated evenly and accurately. Too cold, and it resists shaping. Too hot, and the material can be damaged before the forging even begins.
Timing matters the moment the billet leaves the furnace. From here, the steel starts losing heat immediately. And that means the window for shaping it is already closing.
This is one of the most critical moments in the process. Not because it looks dramatic, but because temperature control is everything. Lose the heat, and you lose the freedom to shape the steel correctly.
Now the force arrives. This is where raw material begins to become engineered material. Not by cutting away metal, but by moving it.
Under extreme pressure, the billet changes shape in seconds. What seems violent is actually deliberate. Force is being directed into the steel with astonishing control.
Forging is rarely one strike and done. The steel is turned, repositioned, and struck again. Each cycle pushes the metal closer to its intended geometry.
Machinery may supply the force, but people protect the quality. Skilled operators read timing, alignment, and movement in real time. Experience is part of the process. Some forgings are made with repeated hammer blows. Others are shaped under the slower, sustained force of a hydraulic press. Different tools, same goal. Controlled shaping under pressure. The shape changes on the outside, but more importantly, the structure changes within. Forging improves the way the metal's internal grain follows the part. That grain flow is one reason forged components are trusted in demanding applications. Strength is not just about the alloy itself. It is also about how the material has been shaped.
Dies help guide the steel into a specific geometry. The process may look rough from a distance, but it is built on exact design. Every contour in the tooling has a purpose.
After the main shaping step, the part is still not finished.
After heat treatment, the surface still carries the marks of the forge.
Scale, residue, and roughness are stripped away.
The part begins to look less like raw metal and more like engineered product. This is one of the most satisfying transitions in the factory. Beneath the scale and fire, the true surface begins to appear. But it still is not finished. Forging creates the near-net shape. Machining refines it. This is where rough strength meets dimensional precision. Some surfaces must meet tight tolerances. Some openings, edges, and interfaces must fit shits. Forging gives the strength. Machining delivers the precision. By this stage, the forging may look complete, but appearance is never enough. In the end, quality steel is not created by fire alone. It is built through timing, force, and that is what turns hot metal into something America can rely on. Thank you for watching. If you enjoyed this inside look at how quality steel is forged in the USA, make sure to like, subscribe,